The demonstration begins on Windows 11 with the HybridOps core launcher. The same command line interface also runs on Linux and Mac OS. The dedicated launcher opens a ready-to-use HybridOps.core terminal. The learner does not need to assemble the underlying tools before starting. Target setup is performed once. Later work is organized by named environment. Before deployment, HybridOps checks the complete blueprint. The pre-flight has 5 required stages. They are: number 1, the private network, the EVNG or GNS3 host, guest networking, and the declared image set and application health check. The operation continues only when its credentials, configuration, secret, and dependencies are ready. A missing requirement is reported against the stage that needs it. This prevents a partial environment from being mistaken for a reusable lab. This is important in teaching. A learner should be able to distinguish an infrastructure failure from an error in the networking exercise they are actually studying. The blueprint now runs the dependency holder. It creates a private network, deploys the EVNG host, configures guest networking, installs the baseline images, and runs health checks. The result is not marked as successful just because the virtual machine exists. HybridOps check the services, database, application interface, and virtualization support required by EVNG. The summary therefore describes a working teaching lab and not only a cloud resource. Private access, guest networking, and cost. Access opens through a private tunnel on the learner's own loopback address. The EVNG interface is not exposed to the public internet. The access view also gives the information inside the lab. The Cloud9 guest network, its gateway, DNS service, and DHCP range. A learner can connect a node interface to Cloud9, request an IP address, and reach permitted external services without manually constructing a second cloud network. Cost is part of the operating lifecycle. The same view reports billing readiness, the estimated fixed hourly cost, and the estimates since the last resource update. The cloud workflow so far was operated from Windows 11. I will now switch to Mac OS and the Proxmox reference lab. The Proxmox part uses the same private loopback access pattern. An example of a realistic teaching topology. The larger topology shows how the operating model can support a substantial teaching scenario. HybridOps manages the life cycle of this entire emulation operation. However, it does not claim to be the network emulator. The main campus includes segmented endpoints and server networks, redundant distribution, identity and access services, endpoint management, and wireless infrastructure. The remote learning site has its own endpoint and server segments. Between them are multiple service provider paths, firewalls, and encrypted connectivity. This scenario brings together VLANs, dynamic routing, first-hop resilience, IPsec, OpenVPN, multi-WAN operation, and hybrid identity services. The authorized pentest workstation provides a controlled place for security exercises. HybridOps managing the lifecycle allows these to exist in complete isolation from institution production and cloud systems. As such, security exercises can be conducted in a safe manner. The value is in the ability to examine how identity, routing, resilience, and security control interact inside one reproducible environment. Here, the cross-site IKE2 tunnel is established. It uses AES-256 encryption, SHA-256 integrity. The installed security association shows packets and bytes in both directions. This is not an idle policy. Traffic has crossed both the protected paths. An exercise can now move beyond basic reachability. Learners can inspect route selection, tunnel establishment, packet counter, rekey behavior, and the effect of a failed path and change security policy. Routing and resilience. This supporting views shows established OSPF neighbor relationships, including routed encrypted paths and active CAP virtual gateway across 4 teaching VLANs. These are useful assessment points because the protocol state is visible. A tutor can ask why an adjacency formed, how a route was learned, which gateway is active, and what should happen during a control failure. When private access closes, HybridOps does not silently leave environments running. It shows the current cost position. The operator can decide to keep the lab, export it before a teardown, or destroy it without an export. In this run, the lab definitions and stopped node states are archived and verified before any cloud resource is removed. Destruction then runs in reverse order. The health stage, images, guest configuration, host and private network are removed. The estimated ongoing running cost returns to zero. The archive can be restored during a later deployment. This lets the learner stop paying for cloud environments between sections without treating the lab as disposable. HybridOps brings readiness, deployment, private access, health checks, practical networking, lab preservation, and cost-aware teardown in one lifecycle across cloud and on-premise environment. The project is open source and actively maintained.